Hi everyone, today we'll be seeing application of Laplace transforms. Solution of ordinary differential equation with constant coefficients. So whenever you have any differential equation with constant coefficient, that is with constant c1, c2, so on till cn minus 1 and cn, then you can solve it using Laplace transforms too. Then where ci's comma I is equals to 1 to so on till n are constants. So now here c1, c2, so on till cn are constants subjected to the conditions at x0, that is y of 0 is equals to some constant k1, y dash of 0 is equals to constant k2, and so on till y power n minus 1 of 0 is equals to some kn. So till nth derivative of y is equals to some constant kn. Now take Laplace transform on both sides of 1 we get. Now this is our equation 1. If we take Laplace transform on both sides, we will be getting Laplace transform of d power n y divided by dt power n plus c1 into d power n minus 1 into y divided by dt power n minus 1 plus so on till cn minus 1 dy divided by dt plus cny which is equals to Laplace transform of f of t. So now individually if we take Laplace transform, we'll be getting Laplace transform of d power n of y divided by dt power n plus c1 into Laplace transform of d power n minus 1 divided by dt power n minus 1 of y plus so on till cn minus 1 into Laplace transform of dy by dt plus cn into Laplace transform of y, which is equals to Laplace transform of f of t. So now we'll substitute the value of Laplace transform of d power n into y divided by dt power n, that is p power n into y bar p minus p power n minus 1 into y of 0 minus p power n minus 2 into y dash of 0 minus so on till y power n minus 1 into 0 plus c1 into p power n minus 1 into y bar p minus p power n minus 2 into y of 0 minus p power n minus 3 into y dash of 0 minus so on minus y power n minus 2 of 0 plus so on plus c n minus 1 into p into y bar of p minus y of 0 plus cn into y bar of p, which is equals to f bar of p. Now taking y bar of p common on both sides, just taking y bar of p common, we get y bar of p is into p power n plus c1 into p power n minus 1 plus so on till cn minus 1 into p plus cn is equals to f bar of p and some constants like this. So this whole constant will be taking as g bar of p. So now this will be f bar of p and this will be g bar of p. Then y bar of p into p power n plus c1 into p power n minus 1 plus so on till cn is equals to f bar of p plus g bar of p. Now let this be h of p. So if you let it as h of p, so you can take this one fraction and this other fraction. So and if you apply Laplace inverse on both sides, we'll be getting as Laplace inverse of y bar of p, which is equals to Laplace inverse of f bar of p divided by h of p plus Laplace inverse of g bar of p divided by h of p, which is equals to y of t. So now this way we can solve this. Let's see a problem regarding this. Problems solved by using Laplace transform, the initial value problem. So this is the initial value problem that we are solving by using Laplace transform. So the problem is y triple dash of t plus 2 into y double dash of t minus y dash of t minus 2 into y of t is equals to 0 with initial conditions given as y of 0 which is equals to 0, y dash of 0 is equals to 0 and y double dash of 0 which is equals to some 6. So all the three are constants. Now given differential equation is as shown, that is this is the equation, and if we apply Laplace transform on both sides, we will be getting Laplace transform of y triple dash of t plus 2 into Laplace transform of y double dash of t minus Laplace transform of y dash of t minus 2 into Laplace transform of y of t, which is equals to 0. So now see the degree, the order is 3, right? So p power 3 into y bar of p minus p square into y of 0 minus p into y dash of 0 minus y double dash of 0. So here the order is 2. So p square into y bar of p minus p 1 degree is reducing into y of 0 minus y dash of 0 minus for order 1 p into y bar of p minus y of 0 minus 2 into y bar of p, which is equals to 0. So now if we substitute the values, since we know that y of 0 and y dash of 0 are equal to 0, so this will vanish, and this will vanish, this will vanish, this will vanish too. So we'll be remain with p cube into y bar of p minus 6 plus 2 into p square into y bar of p minus p into y bar of p minus 2 into y bar of p, which is equals to 0, which again if you want, you can take common all the p terms with y bar of p. So y bar of p, take it out and just take all the p cube, p squares and p and constant terms common. We get p cube plus 2 into p square plus minus p minus 2 into y bar of p, which is equals to 6. Then y bar of p, which is equals to 6 divided by p cube plus 2p square minus p minus 2. Then y bar of p is equals to 6 divided by p square into p plus 2 minus 1 into p plus 2. So now if you observe this can be factorized very easily. If you take p square common, you will be getting with p square into p plus 2 minus 1 into p plus 2, which is equals to 6 divided by p square minus 1 into p plus 2. So now this is again a partial fraction. This is p square minus 1 can be written as p plus 1 into p minus 1 into p plus 2. This so after that, this is a partial fraction. Now this you can directly resolve it as partial fractions. Let's do this. So 6 divided by p plus 2 into p plus 1 into p minus 1, which is equals to a divided by p plus 2 plus b divided by p plus 1 plus c divided by p minus 1. So now you have three different denominators. So now take 6 is equals to a into p plus 1 into p minus 1 plus b into p plus 2 into p minus 1 plus c into p plus 2 into p plus 1. So now observe the coefficient of p square, coefficient of p and constant terms. So after observing that, if you can simplify it, you can solve any two equations. I'm solving the p square coefficient and constant terms. So on solving this, I'll be getting it as 6 is equals to minus b plus 3c, and we have a coefficient of p, that is b plus 3c is equals to 0. So by using that equation, we'll be getting the value of c, and on substituting this value c is equals to 1, we'll be getting the value of b, that is b is equals to minus 3. And then substitute again b and c value. If you substitute in this equation, you will be getting automatically the value of a, that is a is equals to minus b minus c, which is equals to plus 3 minus 1, which is equals to 2. Then y bar of p is equals to we got it as 2 divided by p plus 2 plus of minus 3 divided by p plus 1 plus 1 divided by p minus 1. So now we are applying inverse Laplace transform on this. We get Laplace inverse of y bar of p, which is equals to Laplace inverse of 2 divided by p plus 2 plus Laplace inverse of minus 3 divided by p plus 1 plus Laplace inverse of 1 divided by p minus 1. So now if you take this 2, because it is a constant, you can take it out, and this Laplace inverse of 1 by p plus 2 will become e power minus 2t, and Laplace inverse of 1 by p plus 1 will become e power minus t, and Laplace inverse of 1 by p minus 1 will become e power t. So this is the solution. By using this way, we can find the inverse Laplace transform of a given function. Thank you so much for watching. If any doubts, please do comment.